Everyone, welcome back to my YouTube channel. I am Rishi Raghuvanshi. In this video, we discuss some question of data science and their answer. Let's start. How unstructured data is transformed into a format suitable for machine learning models. Unstructured data such as text, image, or video must be converted into structured numerical format for machine learning. The steps include text cleaning, remove irrelevant characters, punctuation, HTML text, etc. Convert text to lowercase. Now next tokenization. Split text into individual words or token. Now third stop word removal. Remove common words like the, is, etc. which do not add significant meaning. Now fourth lemmatization. Reduce word to their root form. Example running to run. Feature extraction. Use technique like TF-ID. Convert text into space numerical vectors weighted by term importance. Now word embedding. Dense vector representation example word to bag, globy word. Now next, structure format. Represent data as numerical vectors or array for machine learning algorithm. Now, second, importance of legal classification in grievance redressal. Legal classification plays a crucial role in grievance redressal by streamlining line process, automates categorization of complaint into appropriate legal categories. Example IPC section. Now, second, improved accuracy, reduce human errors in classifying complaints, faster resolution, prioritize and routes complaints to the correct department. Next, ensure fairness, provide consistent handling of grievance. Fifth, enhance scalability, handles large volume of complaints efficiently. Third, how TF or IDF word embedding can be used to extract feature from complaint text. TF-IDF purpose: identify important words in the complaint by assigning weights based on their frequency in the document and rarity across the corpus. Example for the complaint theft of my mobile phone. TF-IDF highlight thefts and mobile has important term. Now word embedding purpose maps word into dense vectors capturing semantic relationship. Example words like theft and robbery will have similar embedding, allowing models to generalize better. Both methods help in transforming complete text into format suitable for machine learning classification. Now, life cycle of data science project. First, define the problem. Second, objective. Clearly identify and define the business problem or research object. Key details and tasks. Problem statement, expected outcome, and scope of the project. Tools and library. Problem specific discussion. Data classification. Gather data from relevant sources. Collect structured, semi-structured, and unstructured data. SQL APIs, web scraping, Python Panda. Now data exploration and pre-processing. Analyze and clean data to make it usable for modeling. Handling missing values, outlier detection, exploratory analysis. Then pandas and matplotlib. Now feature engineering. Select or create features to improve model performance, feature selection, extraction, and transformation. Now, Python scalar and feature tool. Now, model selection and building. Choose and build machine learning models based on the problem. Select algorithm and train models and tune hyperparameters. Use a Python scalar, TensorFlow, and PyTorch. Model evaluation. Assess the model performance on unseen data. Use metrics like accuracy, precision, recall, and F1 score. Now, model deployment. Deploy the model into the production environment for real world use. Use APIs, cloud service, or edge device for deployment. Now, monitoring and maintenance. Monitor the deployed model's performance update as necessary. Track drift, retrain model, and handle feedback loops. And Prometheus and Grafana and Python script. Now, communication and reporting. Share findings and insight with the stakeholders. Create visualization dashboard and reports. And Tableau, Power BI, and Python Matplotlib Seaborn. This table cover the essential stage of data science project lifecycle and can be adapted based on the specific nature of the projects and its requirement. Now, next question we have explain the role of text mining in automation grievance retrieval system. List the key steps involved in pre-processing unstructured data. Role of text mining in automating grievance redressal system. Text mining automates grievance redressal system by extracting meaningful insights information from unstructured data, complaint feedback, here how it's contribute. Automated categorization. Text mining classifies complaint into predefined categories, example service issue, theft, etc. without manual intervention, helping route them to the right department quickly. Now, next we have sentiment analysis. Identify the tone of the complaint, positive, negative, neutral. Analyze the prioritization of urgent or high priority issue. Next, we have efficient and query handling. In this, we automatically identify key information, example, complaint type, location issue, to resolve queries or any problem, trigger appropriate action. Now, fourth one, we have pattern recognition. In this, we recognize the pattern or detect trends or recurring issues, helping us to improve services or resolve frequent grievances. Now, next, we have improved human error in interpreting or classifying complaints and ensuring consistent responses and efficient feedback and problem solving. Key steps involved in pre-processing unstructured data. First, we have text cleaning, remove unnecessary characters, punctuation, special symbol, and convert text to lowercase. Now, next, we have tokenization. Split text into individual words or tokens for further analysis. Removing stop words, remove common words that do not combine contribute significant meaning. Stemming lemmatization. Reduce what the root forms, example running to run, to normalize variation of the same word. Now vectorization. Convert text into numerical format using method like TF-IDF or word embedding to prepare data for machine learning models. These steps are essential for transforming raw and structured complaint data into a clean and structured format suitable for automating processing, classification, and response generation. Now, the key difference between K-means clustering and hierarchy clustering algorithm. What 10 are the advantages of hierarchy clear clustering over key means when visualizing cluster relationship. Now, key difference between key means clustering and hierarchy clustering. Clustering approach, centroid based participation, hierarchical clustering, algorithmic bottom or divisive, number of cluster predefined, no need to specify the clusters. Now cluster shape, work with the spherical cluster, can handle arbitrary shaped cluster. Output file, flat partition of data into k cluster, dendrogram tree structure showing cluster hierarchy, computation complexity. Now initialization, sensitive to initial centered selection, no initial selection required. Handling outliers, sensitive to outliers, more robust to outliers. Scalability, better for large data set, not ideal for very large data set. Cluster relationship, does not provide information on cluster hierarchy, shows relationship between cluster in the form of dendrogram. Advantage of hierarchical clustering over key means when visualizing cluster relationship. Dendrogram representation. Hierarchical clustering produces dendrogram which visually shows the hierarchical structure of cluster. This allows us to understand how cluster relate to each other to different level of granularity which is not possible with k-means. No need for predefined cluster. Unlike k-means, which requires the number of clusters to be predefined, hierarchical clustering allow the user to decide the number of cluster at any level while cutting the dendrogram. Better insight into cluster relationship. Hierarchical cluster give a clear view of how clusters are nested with each other, provide a deeper understanding of their similarities and difference between clusters. Now, next, flexibility with arbitrary cluster shape. Hierarchical clustering can handle complex shape of clusters, unlike k-means, which assumes clusters are spherical. This flexibility allows hierarchical clustering to represent real-world data more accurately. In summary, hierarchical clustering excels in providing a visual or intuitive representation of how clusters are related, which can be particularly useful in understanding the structure of data. K-means, while effective for large databases, does not offer this level of insight into cluster relationship. Thank you for watching the video.